All right, welcome back. So we looked at proofs and we looked at our properties of equality, addition, subtraction, multiplication, and division, and talked about how it has to happen on both sides of the equals. And then we looked at substitution, distributive, and combined like terms and discussed how that doesn't have to happen on both sides of the equals. So this combined like terms, oftentimes we get that confused with the addition and subtraction. Remember, addition and subtraction property of equalities happen on both sides of equals, and combined like terms happens on one side. Okay, so let's look at some examples, or let's look at how to apply this in a proof situation. The type of problems we're going to be focusing on are called two-column proofs, and it's a table with statements columns and reason columns. So you're going to have a statement column that lists every step in the problem. We can't skip any steps. Okay? Then you're going to have a reason, and that's the one that tells you, well, why can we write that? Okay? So let's look at an example. Okay? Now, each proof will begin with some sort of given statement, and it's going to ask you to prove something. So, for example, I'm given that 4x plus 5 equals 37, and I want to prove that x equals 8. So we're going to build this table with statements and reasons. So I'm going to write statements, and then I'm going to write reasons. And make myself a little table. Okay? So to start off with, I'm going to look and see, well, what information did I start with? What did they give me? So they gave me 4x plus 5 equals 37. So that's the first thing I'm going to write down. 4x plus 5 equals 37. And why can I say that? Because they told me that's what I'm going to start with. So that was given to me. Okay? All right, so then the next step that I'm going to do is look at my problem. What would I do next? I would probably try to move that 5 to the other side by subtracting it, right? So I would do minus 5 and minus 5 so that would cancel out and become a 0. So my 4x would come down. It's really plus 0, but we don't have to write that. Equals 37 minus 5 is 32. And then next to this, how did I get from the orange step to this red step? Okay, to get from the orange step to the red step, I subtracted on both sides. So that's my subtraction property of equality. Okay? All right. So then, the next thing I would do is I need to get rid of that 4. So I would divide by 4 here and divide by 4 here to get to my next step. So this would cancel out to 1x equals 32 divided by 4 is 8. So x equals 8. Now if I look, that is what I was trying to prove. And here where I said this is what I'm given, so I write given, this is what I'm trying to prove, but I don't write prove. If I write the word prove here, that's kind of like if you're trying to prove a case and you're a lawyer and you go into the courthouse and you say, Your Honor, my client is innocent because I have proof. And then you just shut your briefcase and walk out of the room, right? The lawyer's going to go, okay, but what was the proof? Never mind, your client's going to jail, right? So you have to actually, you can't just write the word proof or proven. You have to actually say, what is the proof that gets you to here, right? Well, what did I do to get from this step to this step? I divided by 4. So it was the division property of equality. Okay? So while we will use given in our proofs, we will never, ever use the word proof, prove, proven, proved, or any sort of version of the word proof. Okay? You will see the given. You will never see the word proof. Now, your last step should always match what you're trying to prove, but it will not have a reason of proof. Okay? All right, watch the next video to see a few examples.